Math Minute 57. Number 1 says Monique weighs 84 pounds. When she is holding her baby brother, she weighs 96 pounds. How much does Monique's baby brother weigh? So I'm going to write a couple things down that they told us in the problem. They said Monique with her brother, when she was holding her brother, weighed 96 pounds. And then it also told us that Monique alone, and when she's by herself, weighs 84 pounds. So to figure out how much her brother weighs, I need to take how much Monique weighed with her brother, and then I'm going to subtract that from how much Monique weighs when she's by herself, and the difference I get will be how much her brother weighs. So I start with 6 minus 4, I get 2. I get 9 minus 8, which is 1. So that means that the baby brother weighs 12 pounds. Number 2 says complete the factor tree. So they're asking me to find the number that if I multiplied it by 5, I would get 45. Well, one way I could do that mathematically would be to do 45 divided by 5. If I did that in the calculator, I would get 9. So that means that 9 has to go in that box. And that would make sense, because if I broke 9 down into factors, I'd get 3 and 3, and 3 times 3 is 9. Number 3, what is the common denominator for 1/3 plus 1/2? So for this kind of problem, we need to focus on the denominator, and I got 3 and 2. And this is the idea of something called multiples. So I'm looking at the multiples of 2 and 3. And multiples just mean that you keep adding the number over and over again. So the multiples of 2, so if I started with 2, and if I add 2 to that, I'd get 4. And if I add 2 to that, I'd get 6. If I add 2 to that, I'd get 8, and so on. You would just keep going. And the multiples of 3, if I started with 3, then I just keep adding 3. So the next one would be 6. 6 plus 3 is 9. 9 plus 3 is 12. And then I want to find, well, what's the smallest number they have in common? So if I look at both of these lists, and I look for the first number that they have in common, it's the 6. So I would say that 6 would be the least common denominator of 2 and 3. And the reason you have to do that when you're adding or subtracting fractions is you have to have the same denominator when you're doing that. So that's why you have to find a denominator that they both have in common, so you can end up adding or subtracting fractions. All right, number 4. Okay, so this is an order of operations problem, which is PEMDAS. Remember, the P stands for parentheses, the E stands for exponents, M is multiplication, D is division, A is addition, S is subtraction. So if I look at this problem, I have parentheses, I have an exponent, and then I have a fraction on the outside of the parentheses, which is multiplication. So the order that we're going to solve this is we're going to do the parentheses first, and then we're going to do the exponent, and then we're going to multiply. So I'm going to start by doing what's inside the parentheses first, which is 3 plus 5. That would be 8. So the next part would be doing the exponent. So inside I have the parentheses now. I have 8 inside the parentheses. And then I'm going to take that to the second power, which means 8 times 8. And 8 times 8 is 64. And then my last step is I'm going to take this 1/2 and I'm going to multiply it by 64. So I'm going to take 1/2 times 64. Over here, I'm going to write 1/2. And I want to write 64 as a fraction, which would just be 64 over 1. Remember, the rule when we're multiplying fractions is we just go straight across. So on top I have 1 times 64, which is 64. And on the bottom I have 2 times 1, which is 2. So then my last step is to just take 64 divided by 2. And I would get 32. So 1/2 times 3 plus 5 to the second power is 32. All right, number 5 says, what is the probability that a student pulled at random from class 1 is a girl? So if I look at class 1 and I look at girls, I see that there's 15 in there. And then I want to say, well, 15 out of how many in class 1? Well, there's 25 total kids. So now I want to simplify this fraction. So I say, okay, what number can I divide into both 15 and 25? Or what's the largest number I can divide into both of them? And I'm gonna say 5 for this one. So I'm going to divide both of these by 5. 15 divided by 5 would be 3. 25 divided by 5 would be 5. So I would say there's a 3 out of 5 chance that I am going to pull a girl at random from class 1. All right, number 6 says, which of the following solves this problem? So we got 2x plus 3 equals 15. So basically what they're asking me to figure out here, they're asking me to figure out, well, what does x need to be for this equation to be true? So this is these are algebra concepts here. So the first thing I want to do is I want to get this 3 over on this side. Because I want to move everything away from the x so I can get that by itself, so I can figure out what that number is. So to move this 3 over here to the other side, I have to cancel it out there. And if I do something on one side of the equal sign, I have to do it on both sides. So those 3's would cancel out. So now I have 2x on the left side. And then I have 15 minus 3 over here, which would be 12. Now my last step is I have to get rid of this 2. Well, this 2 and the x next to each other, that means multiplication. So I want to think, okay, I want to do the opposite of that. Well, what's the opposite of multiplication? Well, that's division. So we're going to divide by 2. So those 2's would cancel each other out there. So I'm left with x on this side. And then 12 divided by 2 would be 6. So I have my answer. X would need to be 6, which is answer D. So 6 is the number I would put in for x to make that equation true. All right, number 7 says complete the analogy. So a circle is to a circle with a line through it as a square is to, well, using that same analogy, you would say a square with a line through it. Well, which one shows a square with a line through it? That would be answer C. Number 8, find 2 pairs of different unequal odd numbers that complete the equation. Okay, so I'm thinking of odd numbers, so that's 1, 3, 5, 7, 9. So what combination of those could I use to get 10? Well, I could use 1 and 9. Those are different unequal odd numbers. And then the other two I could use. To get 10 would be 3 and 7. Those are also unequal odd numbers that I could add to get 10. Number 9, fill in the missing numbers to complete the chart. So the first number